Store STT, a smart warehouse system. Welcome to Store STT, a complete warehouse inventory management system that combines a traditional product catalog with speech-to-text audio narration and an AI-powered chat assistant. Built using a Python backend API and a Flutter cross-platform frontend, the project is designed to provide a multi-sensory experience for both customers and warehouse associates. The project concept, Store STT, simulates a physical warehouse, such as a hardware or building materials store. While users can browse products traditionally, the system's unique feature is that every product includes an audio narration generated via text-to-speech. Additionally, an integrated AI chat assistant allows users to search the catalog and get real-time answers to their questions. The backend API. The backend is a FastAPI server written in Python, sitting on top of a PostgreSQL database. It provides a full RESTful API for managing all store entities. Key capabilities include inventory management, tracking categories, products, technical specifications, and physical warehouse locations. Stock tracking, an inventory log that provides an audit trail of every stock change from receipts to sales. User and chat management, handling user authentication via JWT and managing chat sessions and message history. Audio management, tracking the generation and status of product audio assets. The API is designed for high performance, offering features like pagination, advanced filtering, and automatic OpenAPI documentation. The front-end application. The front-end is a Flutter application that runs on Android, iOS, Linux, macOS, Windows, and the web. It provides a modern, user-friendly interface with several key features. Product browsing, a searchable catalog with category filtering and detailed product cards. Product details, detailed views including technical specs, image galleries, usage FAQs, and integrated audio playback. AI chat interface, a chat screen where users can interact with a language model. The assistant can use tools to search the product catalog and provide intelligent, real-time answers. Cross-platform support. The app is built to work with both local LLMs, like Gemma, for offline use and remote models via an OpenAI-compatible API. The speech-to-text audio pipeline. A core innovation of this project is the automated audio narration pipeline, which follows four main steps. 1. Text generation. A script generates descriptive, template-based text for every product in the database. 2. Audio generation. This text is sent to a local text-to-speech API, which generates energetic wave audio files. 3. Database integration. The file paths and generation status are stored in the database, linking the audio directly to the product. 4. App playback. The Flutter app fetches these audio URLs, allowing users to listen to product descriptions seamlessly while browsing. Additional tools and ecosystem. The project includes several utility scripts to ensure a smooth development and deployment workflow. Database utilities scripts for seeding the database with thousands of realistic products and managing migrations. AI Session Viewer, a specialized tool for reviewing and analyzing AI agent interaction logs. Audio refinement, scripts to transform raw descriptions into more natural-sounding, friendly conversational text before audio generation. System integration and execution. The entire system is designed to be orchestrated easily. From setting up the PostgreSQL database and running the backend API to generating the audio assets and launching the Flutter frontend, the process can be automated. A single execution script is available to start the database, API, audio services, and language models all at once. Conclusion. Store STT is a demonstration of how modern technologies, Python, Flutter, PostgreSQL, and AI, can be integrated to create a next-generation inventory system. By blending product management with speech synthesis and conversational AI, it creates a browsing experience that is truly visual, auditory. Let's see how the database schema and seed scripts were generated. They may include a few errors fixed on the fly. I want to design a PostgreSQL database schema for a new project called Store State that manages warehouse products and customer interactions.
I analyzed the project requirements to design a comprehensive database schema and then checked the project directory to see if there was any existing structure.
I listed the contents of the current directory and found the current and parent directory entries.
I designed a comprehensive SQL schema for a warehouse store database and wrote it to a new file, store.state.zemo.sql.
I successfully wrote the schema SQL file to store.st.zemo.sql.
I've summarized the reasoning behind the database schema I just wrote to schema.sql detailing the purpose of each table and the key design decisions.
I want to create seed data for about 1,000 products across 10 different categories, including all necessary related tables, based on this database schema.
I'll create a comprehensive seed script that generates realistic data for all tables.
I successfully wrote 41839 bytes to store stack_seed.py.
I'm going to add the dependency requirement to a new requirements.txt file, and then check if we need to verify the script.
I successfully wrote 21 bytes to store staterequirements.txt.
I'm going to run a Python command to check if seed.py is syntactically correct.
Seed.py parses OK.
I'm checking the store state stir directory to verify the files were created successfully.
I listed the contents of the current directory and found 3 files: requirements.txt, schema_what_squiggle, and seed.py.
I've summarized the files created, the data breakdown for the seeding script, and the instructions for running the setup.
I'm getting a duplicate key error when trying to run my database seeding script, specifically a unique constraint violation on the category slug.
I identified that duplicate subcategory names were causing slug collisions, so I updated the slug generation logic to include the parent category name to ensure each subcategory has a unique slug.
I successfully updated the code in store_seed.py, replacing one block.
I noticed a potential mismatch between the seed function signature and its call in the traceback, so I'm reading the store_seed.py file to verify the current code.
I read the end of the file, which contains the database connection cleanup and the main function for the seeding script's CLI.
I need help fixing a duplicate key error that occurred while I was seeding my database.
I've identified that the current SKU generation can cause duplicates when product names collide across categories, so I'm reading store_seed.py to investigate the generate SKU function.
I read the file and found several FAQ entries organized by category, including kitchen, safety, and garden and outdoor, for example. In the kitchen section, it covers topics like choosing taps and countertop materials, while the safety section includes information on fire extinguishers and smoke detectors.
I'm searching for the generate SKU and trans products function definitions in seed.py using grep to find their exact locations.
I searched the file and found 3 instances of function definitions and a SKU generation call at lines 297, 321, and 334.
I'm going to read store_seed.py to examine the generate SKU function so I can modify it to ensure uniqueness.
I read the file and found a Python function called generate SKU that creates a deterministic SKU using an MD5 hash. There are 403 more lines in the file that I haven't read yet.
I updated the generate SKU function in store_st_py to use a global counter, ensuring that SKUs remain unique even for products with the same name.
I successfully updated a block of code in store_stt.py.
I'll run a Python command to parse seed.py and verify that it still parses correctly.
Seed.py parses OK.
I'm going to reset the database and rerun the seed script to verify the fix.
I'm still having issues with a duplicate key error during the database seeding process, and I want to make sure the init.db.sh script works as expected.
I identified that the current modulo arithmetic for location generation produces duplicate coordinates, and I've planned to fix it by using nested loops to ensure every combination is unique.
I read the beginning of the file and found several configuration constants, including the number of products, associates, and zones.
I analyzed the location generation logic to identify why duplicates were being produced and planned a fix by adjusting the aisle, shelf, and position constants. I then ran a grep command to check the database schema for any unique constraints on the locations table.
I read the SQL snippet and found the definitions for the locations and product locations tables, along with several index creation statements.
I identified that the modulo arithmetic logic was causing duplicate location entries and proposed replacing it with nested loops to ensure each location is unique.
I read the beginning of the file and found several configuration constants, such as the number of products, associates, and zones, along with the start of a category definitions list.
I identified a bug in the location generation logic that causes duplicate coordinates and decided to read store std.py to implement a fix using nested loops.
I read the file and found a Python snippet that generates and inserts seed data for warehouse locations into a database, including details like zone, aisle, shelf, and position.
I identified that the modulo arithmetic was causing duplicate locations, so I updated the script's constants to explicitly define the number of aisles, shelves, and positions to ensure exactly 40 unique locations per zone.
I successfully updated the file, store std.py, by replacing one block of code.
I noticed that the location generation logic was producing duplicate locations, so I updated the code to use nested loops for generating unique combinations of zones, aisles, shelves, and positions.
I successfully updated the file, store std.py, by replacing one block of code.
I analyzed the mathematical error in the location generation formula that was causing duplicate keys and determined a way to use nested loops to ensure each location is unique.
I read the file and found the initial configuration constants, such as the number of products, associates, and zones, but the output was truncated with 676 more lines remaining.
I noticed that the location generation code still references num locations per jade, which no longer exists, so I'm searching for it in seed.py to locate and fix the reference.
I ran a bash command, but it failed with error code 1 and produced no output.
I'm checking the store std.py file to ensure the location seeding code was properly updated after removing the old constant.
I read the file and found a snippet of Python code that generates and inserts warehouse location data into a database, including details like zone, aisle, shelf, and position.
I'm going to run a Python command to check if seed.py parses correctly after the changes to the location generation.
Seed.py parses, OK.
I've analyzed the logic for location generation to confirm it produces unique combinations, and I'm checking the database schema to verify the unique constraints on the locations table.
I ran a bash command and it returned a SQL snippet for creating a locations table, including fields for zone, aisle, shelf, and position.
I explained how I replaced the old formula with nested loops to ensure unique warehouse locations and provided the commands to reset and reseed the database.
And now let's see how the FastAPI server was generated. It may include a few errors fixed on the fly. I want you to read schema.sql and write a FastAPI server called storeAPI by Pi that provides full CRUD operations for the PostgreSQL database, including course support and pagination for all tables.
I'm going to read the schema.sql file to understand the database structure.
I read the database schema file, and it defines the structure for a warehouse store database. It includes 10 tables, such as categories, products, product specs, and locations, covering everything from product information and inventory logs to associate details and customer questions.
I'm creating a FastAPI server with all CRUD operations, pagination, and course support for all 10 tables.
I successfully wrote 56012 bytes to store-tstore API byte pi.
I've provided a summary of the newly created Store API by FastAPI server, including its features, pagination, and instructions for running it.
I'm getting some errors when running the Store API using run store API.py, and I want you to curl the products yourself.
I'm going to curl the product's endpoint to see what errors are occurring.
I attempted to connect to localhost on port 8000 using curl, but the connection failed because the server could not be reached.
I'm starting the server in the background and then running a curl command to test the product's API endpoint.
Internal server error.
I'm going to check the API logs to see the exact error that's causing the internal server error.
I ran the server and it encountered a critical error. While there were several pydantic deprecation warnings in store API by Pi, the application crashed with a 500 internal server error due to a ASC Quilinea argument error. Specifically, it failed while trying to create a backref named parent on the category children relationship because a property with that name already exists.
I identified a Esquilinea backref collision in the category model and applied a fix to the relationship definitions in Store API by Pi.
I successfully replaced one block in StoreState API by Pi.
I'm going to read the store API.py file to check if there are similar backref collisions with the location and product location models.
I read the file and found the Python class definitions for product and product spec, which include database columns for things like SKU, name, and price.
I identified a naming conflict between the associate and customer question models, so I'm restarting the server to test the API endpoint.
Internal server error.
I want you to use the env file for the PostgreSQL connection settings, as the database is running in a local Docker container.
I'm going to read the env file to check the current PostgreSQL connection settings, so I can update the API script.
I read the file and found the PostgreSQL configuration settings, including the database name, user, host, and port.
I'm checking the PyProject TOML file to see if python.env is already listed in the project dependencies.
I read the project configuration file and found the metadata for store states, including dependencies like FastAPI, SQLNA, and Uvicorn.
I'm going to add python.env to PyProject TOML and then update the database connection to use environment variables while fixing its Esquilinea backref collisions.
I want to run the Store API by server using uvrun, and then curl the product's endpoint to check if it's working.
I'm going to look at the project structure to understand how to run it by reading store.depapi and listing the files in the directory.
I listed the directory contents and found 22 items, including API readme.md, audios, and main.py.
I'm starting the server in the background, and then using curl to check the product's endpoint.
I ran a command that queried the product API, and I successfully retrieved a list of 20 products. The response included details for items like Wireman cables, Havells switches, and Siemens breakers, along with pagination info showing there are 1,000 total products available.
I verified that the server is running and returning the correct product data. Then I tried to stop the background process to clean up the environment.
Server stopped.
I realized I had stopped the server instead of running it, so I ran a command to restart the Uvicorn server in the background.
I ran the bash command, but it produced no output.
I'm going to run a command to check the HTTP status code of the product API to see if the server is responding.
20 Sigurd.
Server is back up and running on port 8000. The API Vival v1 products endpoint returns HTTP 200 with 1000 products, paginated 20 per page. Everything is working correctly.
Let's continue watching how the OpenAPI specification YAML file was generated. I want you to read storeapi.py and create an openapi.yaml file that describes all its endpoints.
I'm going to read the store API.py file to identify the endpoints so I can create an OpenAPI YAML documentation.
I read the file and it contains the implementation of a FastAPI application for a store inventory management system, including SQLNA models, Pydantic schemas, and CRUD endpoints for categories, products, locations, and associates.
I noticed the file was truncated, so I'm going to read the remaining part of store API py, starting from offset 13334 to find the customer questions endpoints.
I read the file and found the API route definitions for managing associates and customer questions, including endpoints for creating, retrieving, updating, and deleting them, along with a health check endpoint.
I identified all the API endpoints and their associated models. Then I wrote the complete OpenAPI specification to store STT open_act YAML.
Successfully wrote 57114 bytes to store OpenAPI John Amel.
I've provided a summary of the newly created OpenAPI.yaml file, detailing the endpoints and schemas included.
It's the turn to see how the Flutter cross-platform application was generated. It may include a few errors fixed on the fly. I want you to read the OpenAPI.yaml file and write a Flutter application in a folder called Store App that features a product listing page with search and category filters, along with a detailed product view.
I'm going to read the OpenAPI spec file to understand the API structure before building the Flutter application.
I read the OpenAPI specification for the Store STT API. It defines a RESTful API for store inventory management, covering various modules like categories, products, specifications, usage, images, locations, and more.
I'm going to read the rest of the file to see the remaining schemas.
I read the file and found several schema definitions, including structures for product locations, inventory logs, associates, customer questions, and a health check response.
I summarized the API schemas required for the Flutter app, and then ran a command to scaffold the new Flutter project.
I tried to create the Store app project, but the process failed because I couldn't connect to GitHub or the pub.dev package repository. It looks like there's a network issue preventing me from resolving the host names.
I'm checking if Flutter is available on the system and verifying its version to see if I can proceed with a manual project setup due to network issues.
I ran the Flutter version command and found that I'm using Flutter 3.41.1 on the stable channel, along with Dart 3.110.
Since I don't have network access to use Flutter Create, I'm manually building the project directory structure using a bash command.
No output.
I'm creating the pubspec.yaml file to set up the dependencies and configuration for the Flutter application.
I successfully wrote 340 bytes to store state store app pubspec.yaml.
I'm planning the structure of a Flutter application and have started creating the data models, beginning with the pagination class.
I successfully wrote the content to store STT store app liblib models pagination Dart.
I'm going to create the remaining model files and services, starting by writing the category model to store state store app lib models category Dart.
I successfully wrote 667 bytes to store state store app lib models category Dart.
I'm continuing with the other models and will write the product class to a new file.
Successfully wrote 1323 bytes to store state store app lib models products Dart.
I'm continuing to create the remaining model files by writing the product spec Dart file to the project directory.
I successfully wrote 516 bytes to store store app lib models product spec Dart.
I'm continuing with the remaining model files, and I'll write the product usage Dart file to define the product usage class.
I successfully wrote 544 bytes to store let's stay star store app lib models product Dart.
I am writing the product image Dart model file to define the structure for product images.
I successfully wrote 712 bytes to store skate store app lib models product image Dart.
I'm going to continue writing the remaining model files, starting with the location Dart file.
I successfully wrote the content to store state store app lib models location Dart.
I'm going to continue with the remaining model files by writing the product location model to its designated path.
I successfully wrote the content to store app scap lib models product location Dart.
I'm going to write the customer question Dart model file to the models directory.
I successfully wrote the content to store app lib models customer question Dart.
I'm creating the API service Dart file to handle all the HTTP requests for our application.
I successfully wrote the content to store STT store app lib services API service Dart.
I'm going to create the UI widgets and screens by writing a new product card widget to a Dart file.
I successfully wrote the content to store estate store app libwooddactis product card dart.
I'm continuing to create the remaining widgets by writing the code for the search filter bar widget to a new file.
I successfully wrote the content to store state store app libwooddactis search filter bar dart.
I'm creating a new widget called section card in a new file to serve as a section header for the product detail page.
I successfully wrote the content to store app libwooddax section card.dart.
I'm creating the product screen to implement the main product listing page.
I successfully wrote 747 bytes to store app libscreeds products screen dart.
I'm creating the product detail screen to display all relevant information for a selected product.
I successfully wrote 200,000 bytes to store app liblibscreens product details screen.dart.
I'm going to create the main Dart file to serve as the main entry point for the Flutter application.
I successfully wrote 1,297 bytes to store st2 store app lib main.dart.
I'm going to create the analysis options.yaml file with specific linter rules.
I successfully wrote the content to store state store app analysis options YAML.
I'm creating a readmio MD file for the project to document its features, configuration, and structure.
I successfully wrote the content to store state store app readme.md.
I checked the Flutter templates directory to see if I could find a template to use for creating the project structure.
I listed the contents of the directory and found several items including app, cocoapods, plugin, and template minifast.json.
I'm checking the contents of the Flutter app template directory to see if I can use it to scaffold the project files.
I listed the directory contents and found 13 items, including android.tmpl, lib, and web.
I decided to manually create the essential project files for a minimal Flutter setup, starting by writing a git ignore file.
Successfully wrote 918 bytes to store st store apt-gitignore. I successfully wrote 672 bytes to store store app ios runnertelic xcode project proj.
I'm going to create a new index.html file in the web folder with a minimal HTML structure.
I successfully wrote 156 bytes to store app webindex.html.
I'll create a basic test file to verify that the store app loads successfully.
I successfully wrote 290 bytes to store app test wocats test dart.
I'm running a bash command to list the files in the store app directory to verify the project structure.
I searched the directory and found a list of 40 files, including various Android and iOS configuration files, such as build.gregl, androidmanifest.xml, and appdelegate.swift.
I'm going to check the lib directory to see if there are any duplicate files, or if the directory structure is correct, following the partial failure.
I searched the directory and found 16 files, including main Dart, category Dart, and product Dart.
I'm going to check the pubspec.yaml file to see if the Flutter-generated version or my custom version is being used.
I read the file and found the configuration for the store app project, which includes its version, dependencies like HTTP, and the required Flutter SDK.
I'm checking the contents of the store app ios directory to see if the necessary files are in place.
I searched the store app ios directory and found a long list of files, including configuration files like appframeworkinfo.plist, several assets in the app icon.appiconset, and various iOS project files.
I'm going to perform a final tree listing to show the complete project structure and verify the Dart files and configuration.
I searched the directory and found 21 files including analysis options.yaml, main Dart, and several model files in the libmodels directory.
I'm going to check the line counts of the Dart files in the project to verify that the key files are intact.
I ran a command to list the files in the project along with their line counts. I found 15 files, including several models like category Dart Dart and product Dart, as well as screens such as product detail screen Dart and products screen Dart.
I've provided a summary of the completed Flutter application, including the project structure, key features, and instructions on how to run the project.
Finally, watch the demo of a few user acceptance test cases are applied in the Flutter Linux application.
Welcome to the Store STT application demo. This is a warehouse store inventory management system that combines product browsing, speech narration, and an AI chat assistant. In this video, we will walk through 3 use cases: logging in, browsing and searching products, viewing product details with audio playback, and using the AI chat assistant to search for specific items. We begin at the login screen. The screen displays a storefront icon at the top, followed by the app title Store STT and the subtitle Sign in to use the chat assistant. Below that, we see 2 input fields, an email field with an envelope icon, and a password field with a lock icon and a visibility toggle. At the bottom are a blue Sign In button, a Browse Products Without Signing In link, and a Create an Account link. I click into the email field and type test.user@domain.com. The text appears in the field. Next, I click into the password field and type test1234 at symbol. The password characters are hidden as dots for security. A small eye icon on the right side of the field lets me toggle password visibility. I tap the blue Sign In button. The button briefly shows a loading spinner as the app sends my credentials to the backend server. After a moment, the login succeeds and the app navigates to the product screen. I am now on the products screen. The app bar at the top reads Store Products and shows 2 action icons, a refresh icon and a logout icon since I am logged in. Below the app bar is a search and filter bar. The search field has a magnifying glass icon and placeholder text that reads, Search products by name or description. To the right of the search field is a category dropdown currently set to all categories. Below that is pagination information showing the total number of products and page navigation arrows. The main area displays a list of product cards. Each card shows the product name in bold, a short description, a price badge in blue, a category chip, and the brand and manufacturer names with small icons. In the bottom right corner, there is a floating action button with a chat bubble icon. This button opens the AI chat assistant. I will use it later in this demo. Now I want to search for breaker products. I tap the search field and type the word breaker. As I type, the app waits briefly for me to finish typing, then sends a search request to the server. A loading spinner appears in the product list area. The results load, showing only products with breaker in their name. I can see products from brands like Schneider, Siemens, ABB, and L&T. Each card shows the product name, description, price, and category. The pagination indicator updates to reflect the filtered results. I scroll down through the list of breaker products. I can see multiple items, circuit breakers of different sizes and types, from various manufacturers. Each card is tappable to view full details. I tap the first product card in the list. The app navigates to the product details screen with a smooth transition. The app bar now shows the product name as the title, and there is a back arrow on the left. The detail screen loads all the product information from multiple API calls. I can see a loading spinner briefly, then the full product details appear. At the top is the product header card. It shows the product name in large bold text and a price badge to the right. Below the name is the product description. Then, a series of property rows display: SKU, category, brand, manufacturer, weight in kilograms, dimensions in centimeters, and status showing active or inactive. At the bottom of the header are the creation and update timestamps. Below the header is the specifications section. It has a wrench icon and the title Specifications. Inside, I see a list of technical key value pairs. Things like voltage, current rating, pole count, braking capacity, material and warranty period. Each specification has a bold label on the left and the value on the right. Next is the Images section, with a picture icon. It shows a horizontally scrollable gallery of product photos. The primary image has a thicker blue border. Each image is 180 by 120 pixels. Then comes the product audio section with a headphones icon. It has a hint text that says, "Listen to a description of this product." There is a play button, a large circle with a play triangle inside, labeled Product Assistant. Below the play button is a progress slider and time displays showing the current playback position and total duration. I tap the play button. The audio starts playing. The play icon changes to a pause icon. The progress slider begins moving from left to right as the audio plays. The time counters update in real time, showing the current position and total length in the format minutes:seconds. The audio is a text-to-speech narration describing this product, what it is, its use cases, when to use it, when not to use it, and alternative products. I can hear the product description being read aloud. I continue scrolling down past the audio section. The next section is Usage and FAQ with a help icon. It contains expandable tiles. Each tile shows a common customer question. I can tap a tile to expand it and read the answer. Below that is the Locations and Inventory section, with a location pin icon. It shows the total inventory count in the title. Each location card displays the warehouse zone, aisle, shelf, and position, along with the current quantity. In-stock items have a blue badge, and out-of-stock items have red badge. The last section is Customer Questions with a forum icon. It shows questions submitted by customers, with optional answers and resolved badges. Each question has a timestamp. Now I scroll back up to review the full product detail page. Everything is organized in clearly separated section cards, making it easy to find the information I need. I tap the back arrow in the app bar to return to the product screen. The product detail screen slides away, and I am back on the product listing with my breaker, search still active. Now I want to use the AI chat assistant. I tap the floating action button in the bottom right corner, the one with the chat bubble icon. The app navigates to the chat screen. The chat screen has an app bar titled Store Chat Assistant. On the left is a back arrow that takes me to the products screen. On the right is a new session button with an add comment icon. The main area shows the message history. Since this is a new session, it displays an empty state with a chat bubble icon and text that says, "Start a conversation," and ask about products, inventory, or anything else. At the bottom is the input area. There is a rounded text field with the hint, "Ask me something," and a filled send button on the right. I tap the text field and type my query. I type search for polycab square items, display SKU, name, description, price, weight and dimension details as table. I tap the send button. My message appears as a blue chat bubble on the right side of the screen. A typing indicator appears on the left, a small circle with a loading spinner, showing that the AI is processing my request. The AI receives my message and determines that I want to search for products. It invokes the search products tool with the argument name equals polycab square. A bot message appears saying, calling search products, name, polycab square. The app executes the tool call. It sends a request to the product's API, filtering by name. Another bot message appears, executing function. The API returns a list of matching products as JSON data. A third bot message confirms, function completed and products found. The AI then generates a final response, formatting the product data as a markdown table. The table appears in a chat bubble on the left side, next to a smart toy icon representing the AI assistant. The table has columns for SKU, name, description, price, weight, and dimensions. Each row shows the details of one polycab's product. The markdown table renders beautifully in the chat interface, with proper alignment and formatting. I can see all the product information I requested, the SKU codes, full product names, descriptions, prices in dollars, weights in kilograms, and dimensions in centimeters. I scroll through the conversation to review the full exchange, my original query, the tool call notifications, the function completion message, and the final formatted table response. This demonstrates how the AI chat assistant can perform natural language queries, invoke tools to search the product catalog, and return structured, formatted results, all in a conversational interface. In summary, we have demonstrated 3 complete use cases in the Store STT application. First, logging in with email and password. Second, searching for breaker products, viewing a product's full details including specifications, images, usage information, inventory locations, and playing the audio narration. And third, using the AI chat assistant to search for polycab square items and receive a structured table of product details. The Store STT application combines traditional product browsing with speech narration and AI-powered conversational search, creating a rich.
Thank you for keeping to the end with us. Don't forget to subscribe and like this video if you found it useful.